Okay, we go for next example on mesh analysis, right? In this question, we need to find the value of V naught for the following circuit, right? So remember, in mesh analysis, we are using KVL, right, around the loop to get the uh, unknown current or mesh current for every loop, right? So in this case, right, because we are looking for the value of V naught, so therefore we are using the mesh current in order to find the value of our V naught. Okay, so if you see here, okay, so we have three meshes, and then we need to assign a current for every mesh. So I choose to use a clockwise direction for every current, so therefore, all right, so I would say this one is I1, and then this one is I2, and then this one is I3. Okay, so if you see here, the voltage that we are looking for is actually the voltage drop across your 6 ohm over here. So because actually this, you are given V naught as a direction, so therefore actually if you want to know the sign of this V naught, actually, okay, so assuming V naught, this is not the direction of the currents, guys. This is actually uh, 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 the direction for voltage, so therefore this would be plus and this would be minus. All right, so don't be confused, okay, because in this question they are using uh, arrow to indicate the voltage V naught, but this arrow actually, as you know, usually uh, for voltage, right, for let's say for voltage, okay, so usually this is plus minus, and then usually the direction of the current for voltage is actually that way. Okay, oh, okay, so therefore for this one, okay, the direction of the voltage that we are looking for, actually the sign, sorry, not the direction, the direction of the voltage that we are looking for actually plus minus V naught. Okay, so if you see here, before we start, we know that uh, you can get this sign, plus minus sign of V naught, due to the direction of the current I2, because we know if the current flow this way, so therefore the voltage, the voltage drop across V naught would be plus minus like this. All right, but at the same time you always need to know at 6 ohm, okay, which is V naught, actually you need to consider both current I2 and I3, so therefore at the end V naught will be I2 minus I3 times 6, right? So therefore you need to find the value of I2 and I3, okay, and then we can calculate our V naught value. Okay, so this one, okay, so we do a mesh analysis for mesh 1, okay, KVL equation for mesh 1. Okay, if you see here, so this is the direction of the current I1. Okay, so at this loop you have a current source, guys, so therefore it makes your analysis become easier, because we can say that, okay, I1 is actually the same direction with your 4 ampere over here, so I1 is actually equal to 4 ampere. Okay, so this is our first equation. And then next we go to the mesh number 2 over here. So this is your current I2 flowing clockwise direction. So if you see here, we also have a 2 ampere current source at your mesh 2. So and then at this mesh, okay, the direction of the I2 flowing that way, right? So if you do around the loop, so this is the direction of I2. So the direction of I2 is uh, 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 anticipate is a different direction with your 2 ampere current source. So therefore I2 is actually negative 2 ampere, guys. Okay, why? Because we have a different direction of the between I2 and 2 ampere. So it become negative because of the direction, but the magnitude actually the value of I2 is equal to 2 ampere. So now we have I1 and I2. So we know that in order to find your V0, we need to find also I3 value. So therefore, in order to find I3, we need to do a KVL equation at your I3. So KVL at mesh 3, okay. So therefore, this one, due to the current I3 flowing in this mesh, so this is plus minus, this is plus minus, it would be plus minus, guys. So therefore KVL, we can say that V 6 ohm plus V 3 ohms minus 41 volt plus V 4 ohms is equal to 0. Okay, and then we need to write this equation in a form of a current resistor. Okay, so therefore at 6 ohm, okay, at 6 ohm, looks carefully at 6 ohm over here. So you have two current flowing at your 6 ohm, and then the sign of your 6 ohm is actually due to the I3, so plus minus over here. So therefore we can write the equation for 6 ohms actually using Ohm's law, IR, so which is I3 minus I2 times 6 plus, right? So for this one, plus minus, we have also two current flowing at 3 ohm, which is I1 and also I3. So therefore I3 minus I1 times 3, and then okay, minus 41 volt, okay, plus R4. Over here you only have I3, which is I3 4 ohm, I3 4 equal to 0. So elaborate this equation. So you got, okay, so here I elaborate this equation. So what you have is actually 6I3 plus 3I3 plus 4I3 is actually equal to 41. 41, this one plus 6I2, okay, this one plus 3I1. Okay, so we know that I1 is actually equal to 4 ampere and I2 equal to negative 2 ampere. So substitute this equation into this equation. So therefore this one will become 13I3, okay, 13 equal to 41 plus 6I2 is negative 2. So negative 2 plus 6 times 6 equal to minus 12 plus 3I1 is 4 is actually equal to 12. So this one is actually we can eliminate. So therefore we can say that I3 is actually 41 divided by 13, which is equal to 3.15 ampere. Okay, so now we have I1 equal to 4 ampere, I2 equal to negative 2 ampere, and I3 equal to 3.15 ampere. So therefore we can calculate the value of V naught. Alright, so V naught, okay, actually equal to I2 minus I3 times 6. Okay, I2 equal to negative 2 minus I3 equal to 3.15 times 6. So therefore, okay, therefore this one will become finally negative 30.9 volt. Okay, so we got the same answer as the solution over here. So therefore, V naught equal to negative 30.9 volt.